So the thing I like to start presentations with is the acknowledgement of how beautiful and amazing life is before I get into our problems here in St. Louis. So, and one of the aspects that's so beautiful about life is that we are very privileged to live in this particular time in history. Very much a unique time that is full of possibilities and hope for to be kind of find a balance with nature, with each other, and with chaos. So I'm going to play. My name is Michael Hundelt. I'm with a nonprofit called Energy Care, and I'm going to talk to you about our new social enterprise called TerraLock. And I'm going to go play our CAD rendering of our subterranean geo-cooled data center. I designed this particular invention to be the most efficient, most environmentally sustainable data center ever built. Okay, 40% of the overhead for above-ground data centers are that money spent for cooling systems and to cool the hardware. And so when you use the ground, which is a steady between 50 and 60 degrees Fahrenheit, you can save that money and be that much more green. The TerraLock is all about affordable housing. Okay. Yes, the data center is going to be uniquely profitable. Those profits are going towards nonprofit entities that are going to be existing within the affordable housing units. So we escape here. So the big picture problem here in St. Louis is that the life expectancy in Wildwood is 91 years old. In Kinloch, it's 55. And then another amazing fact is that one in three people in the city are living in poverty. How did this happen? Who cares? We gotta look forward. And one of the ways that I want to tackle revitalizing the north side is through addressing what affordable housing is, how it's built, and whether or not it's supported. So like, who remembers or knows about Pruitt-Igoe? Raise your hand. Okay, so there was an enormous amount of slums downtown St. Louis before Pruitt-Igoe. They built all these structures, put people in there, and then they were unsupported. They just kind of left them to their own devices. The elevators didn't go all the way up, and people ended up like getting robbed in the stairwells, amongst other things. So in order to learn from that, I've designed this mixed-use, multifamily, affordable housing to be placed above ground, above the data centers, to not only take advantage of that heat from the servers, but also kind of use that infrastructure and profits to run in-house nonprofits providing services to expand the personal agency and housing security of each affordable housing resident. And the key factor here is its location being adjacent to the NGA site, which is like the really good news here. The NGA site, the NGA West, is a $2.3 billion project going into the heart of the urban decay here in St. Louis, and placing our affordable housing adjacent to that will allow us to link up with an intranet, fiber optic cables to the NGA site and let them have dedicated servers, and then also provide co-location cloud services to the general public as well. Being able to partner with the NGA and be in that area, because the city has kind of promised the NGA that they will kind of clean up and be able to secure the area for this massive project will kind of lend towards the redevelopment effort. What I want to mention to you is our team. So together with the Executive Director of Energy Care, I'm the Associate Director, we've linked up with WashU. We have 6 interns now, 4 business analysts, and 2, one's undergrads there, one's marketing, and one's business development. What we're trying to accomplish is we're going after a couple things. I'm going to be presenting, hopefully pitching at the Wells Fargo Enterprise Partnership Housing Challenge. That's a $2.5 million grant. The Arch grants and the Rise of the Rest. What's going to differentiate TerraLock from all the other competitors is not only the technology that can benefit us all, being that the data centers across the world are going to represent 3.2% of the carbon footprint. And saving 40% of that energy will drastically reduce that if we put these data centers underground. I think one of the things that I forgot to mention is the IP. So let me take you through how this invention works. So it's a reciprocating, it's a very simple reciprocating movement. There's 2 boreholes that go, depending on if you want to squeeze a 10,000 square foot data center into a borehole, you're going to have to go down 1,000, 2,000 feet underground. And so you have 2 adjacent boreholes that go 1,000 feet down, and what you have is imagine a monorail taking all your blade servers, your IBM blades, pizza boxes, and imagine a roller coaster type of rail system that is all USB jacks. And imagine if those IBM blades have a USB jack attached to them, and you just kind of stack them into the roller coaster. Instead of seats, it's all blades. Okay, and on the inside wall of each of these boreholes is a third rail system that delivers power, and as this chain of servers goes down into one borehole and sits there and allows the earth to absorb all the heat, that heat exchange is pretty efficient because there's really no air, it's a vacuum, and all the space that's left over is going to be filled with dielectric fluid and dielectric grease. So once the earth has reached its maximum capacity of absorbing the heat from the servers, the sensors will trigger a movement of the chain of servers from one borehole to the other. And that movement is actually one of the key factors of the design, because it allows for complete automation of maintenance. So if you want to draw up a blade because it's old or broken, you can have someone in Alaska trigger the chain to move precisely, bring that blade up to the surface. Some of the key attributes of this design, being that it's underground, first and foremost, it protects against theft. It's a deterrent against physical capturing of data. But secondly, it prevents from catastrophes, from EMP events. We've had the luxury of living in a peaceful time period in human history where we haven't had a giant solar flare that has wreaked havoc on the CPUs that we enjoy and hold so dear. But if you have a solar event and there's a giant EMP burst from the ionosphere, it could jeopardize our whole infrastructure. And these particular data centers, being underground, will protect against that. Um, one of the coolest aspects of TerraLock, and I want to really emphasize this, is that it's a social enterprise. You know, yes, you could, if let's just say Joe Blow invents something that could generate millions of dollars, and then he goes and buys a house in the Hollywood Hills, and then has a family and lives a happy life. I don't think that's a life worth living if you abandon entire swaths of communities and you allow people to suffer. So in an effort to kind of revitalize St. Louis, I want to bring this innovation and encourage the disruption of a couple of industries. Nonprofits. I think nonprofits should not spend 80% of their time begging for money. I think that every nonprofit should have a subsidiary for-profit enterprise, allowing them to deliver services that they would like to deliver, solving their mission. That's the one thing that I bring to the table at Energy Care, is that for 37 years they've been doing a lot, saving people from the extreme temperatures, hot and cold, but they have not been able to address the core issue of sustainable housing, being able to have personal agency, and yeah, it's about addressing poverty really and oppression. And I have to get back on track here. So why now? What's so important? Why should we revitalize St. Louis' most blighted area right now? And it's because we are blessed. We're very fortunate to have the National Geospatial Agency choose our location for this $2.3 billion project. And what we have to do is really accommodate for this momentous occasion, and we can do that by developing, kind of transforming the Midwest and St. Louis in general as the data center hub that it should be, because we're centrally located. And if you know anything about cloud computing, the best cloud is the local cloud. And if we can transform St. Louis and niche into super environmentally sustainable data centers that support thriving communities, we can start to repair what we should have done, 50 years ago. So it's a little embarrassing, but I think we have what it takes as a community to come together and participate in kind of restructuring what a home is. But one of my favorite quotes from my grandfather is that a home is a sacred place, but it doesn't necessarily have to be a nuclear family type of home. We can bring back communities in a special way. So there's a social engineering aspect to this company as well. For the pilot project facility, I'm reaching out to an extended family of low-income residents of St. Louis to all exist under one roof and utilize collective bargaining and an aspect of togetherness that will conquer very social, some of the problems of social economics that affect us when we live in separate homes. And if you want to discuss that with me at a different point, that's another time. But essentially what I would like to end on is that we have some socioeconomic problems here in St. Louis. There's climate change, there's this overall greed. But what we can do as a community is come together around a single aspect of redevelopment, and that can start with the home, the supported home. And that's it. I appreciate your time, and hopefully you guys can check out energycare.org. What I want to gain from this event is be able to practice. As you can see, I need to really hone in on this my presentation. It's just a lot of information to relay. But if you could check out the website in your free time and give us some give us some notes, because we're going to be competing for the Rise of the Rest and the ARCH grants and everything that's available for us. So we're interested in grants since we are a social enterprise. So thank you, and I'll take some questions.
All right.
Yep.
Please raise your hand. We don't have microphones, so we'll start here.
Okay.
She was first.
Oh, well, she's not. I'm in charge.
Just trying to understand. Really sounds great, fantastic. And since I've been involved in data centers, I know that data centers they waste a lot of energy, right? And a lot of heat is produced and stuff. Question is, the idea looks fantastic. Have you done any kind of any kind of proof of concept or any kind of small scale, sort of even software-based modeling of some kind to show how it actually works?
Yes. So the quick video that I showed at the beginning was the animation of our CAD rendering. We're in the process of taking that CAD rendering and putting it in computer modeling software. And then also, when we get funding, I'd like to build a scale model and run some real testing there underground. Yes.
So I think this is a really intriguing concept. I love it. I live in the city, partially because I believe in the city is bringing back.
Oh, very good.
It's exciting.
Yeah.
And you did a great job with that microphone, so thank you. I actually have two questions. Number one, I'm a little bit unclear on how the actual role your organization plays, whether you guys are building and operating the data centers, or whether you're working on the community side, or whether you're tying those two together. The second question is why a 501c3 and not a B Corp?
Okay. TerraLock is the for-profit subsidiary of Energy Care. Energy Care will keep on chugging, doing its own thing, providing energy-related services to the people that are in crisis. And it just so happens that Energy Care's clients, a lot of them exist in the area that the NGA is going into. So it's really a unique opportunity for Energy Care to educate people on the status of the disintegrating housing stock that people are living in. The fact that our local governments aren't enforcing code, and if they did, we'd have a lot of people that are homeless. And so we just can't kick the can down the road anymore. And this is an idea of how to drastically, change our perspective on what affordable housing is, how it's supported, who can live there, I just want to address how it's just embarrassing. I don't know.
Oh no, you're preaching to the choir here.
Yeah. Okay.
Do you know if local zoning ordinance support this type of data processes that are underground, or is the policy change something that might have to parallel your business development efforts?
So in order to dig 1,000 feet down?
That and putting that particular material underground.
Oh, sure. So St. Louis has a long history with the brewery of using geothermal digging, using the river to cool beer, and we have a lot of we have that whole steam infrastructure that warms a lot of the. To be honest, I don't know the particulars about that specific ordinance, but I know that oil drillers and just if you have enough money, we have the technology to keep everything out from. If you put a sleeve in the geothermal wells, there can be a lot of insured. We can be totally insured on anything that would escape into the groundwater, because it's just the science behind drilling and putting that shielding into boreholes is that advanced. But yes, we're going to cross that bridge when we get there. I just know that the progress that can be made and the potential profits will outweigh the risk-adverse St. Louis community that we all know and love.
Awesome. Yeah, and I agree with you. I just know that that's always one obstacle that can either develop after the fact or before. So it's always good to network with those type of people during the development process.
we hope to have a strategic partnership with an oil drilling company in order to design and really kind of sidestep some of those issues.
Great, thank you. Good luck.
Thank you.
So, quick question. If it's too unfair to ask you this, that's fine too, depending on what your background is. So, within a typical data center or co-location facility, the primary storage, even though it's trending towards flash drives, is still spinning drives. If you're moving those drives, what do your models show is the effect on uptime? And generally speaking, when you have spinning drives at 10,000 to 14,000 RPM, they don't like to be moved very much.
So it's a really great question, because absolutely, you got centrifugal force, and when you move a disk that's spinning, you're gonna affect it. In order to counteract that, TerraLock's chain of servers will move so slowly, and if it comes to it, we'll have mirrored instances on identical facilities, so that when it's moving, the identical server is kicked on, and it kind of steps in for that moving. But essentially, what we were hoping for is that the server chain is moving so slowly that it won't affect anything.
Okay, thank you.
Have you considered partnering with some of the companies who are setting up data centers everywhere, including the super users of data centers like a Facebook or Amazon or Google, as well as co-location companies? Is that a natural place to kind of see if they might be interested?
I think the only value I can take from those super sites is their hardware. The actual infrastructure, since I'm kind of disrupting how data centers are designed entirely, it's kind of like a Google X project. Maybe I can talk to them, but being able to essentially, I'm trying to build a harness so that a blade server can just is a plug and play. So I don't have to redesign the actual server motherboard. And beyond that, it's all kind of new. And I don't think that, since people the data centers hasn't changed in such a long time. The most pushback I get is from people that are data center designers, and they're like, why would you bring the heat source down to the coolant? Why not bring the coolant to the heat source and keep it all the way it is? And then obviously my objection is that you'd be eliminating the entire the efficiency of the heat exchange.
Yeah, I think that sounds fine. Most of these data center companies or companies who are forming co-location centers, sustainability for them is one of the things that they're trying to do.
Right.
And they also get blamed by communities, like, you're moving to our community, but what's going to happen here? It's going to be a huge suck of power right there. So there's that angle. And then the other thing is that your solution is obviously using the earth. And I've seen some of these types of centers, I think I mentioned it to you, being used in Finland and in Sweden, and they're developing these because there's a lot of cold kind of icy conditions there. So the question is, have you done any calculations in terms of the savings that you would have to drive the ROI, to drive the total cost of ownership down for these co-location type facilities or these super users? Because then it becomes more of a business as well as a sustainability initiative, and more of those that you put together, the more they might be interested, and motivated to work, maybe even putting this into practice.
Yes. Okay. I think this is working out. I've learned a trick. You have to kind of cup the mic. Okay? So right off the bat, it's 40% of that overhead cost to those cooling systems. I used to work for Emerson Electric, and their data center was like top notch, and the
Okay, whatever. One of the they really emphasize on putting the solar panels up and running their cooling systems and their backup cooling systems and their backup power systems, and they have these giant generators. And so you don't need a cooling system for this because the Earth will constantly be cool. And maybe a backup power system, but there's really not going to be a lot of power to move the server train from one borehole to the next. But right off the back of the napkin, I'm saving a drastic amount of money, not having that cooling system, not having security, no lighting, less personnel. We're literally going to be able to design an automation that has a kind of like the engineering behind a handgun or any kind of weapon that swaps out bullets. So when there's a bad server, it could automatically bring that blade and swap it out like a shell cartridge.
Okay, I love what you're trying to do. I'm going to tell you why all those server people say to use the Earth to cool things and bring it up.
Yep.
Your biggest issue is water. Have you ever dug a well before? Because what you're doing is you're digging a really long well.
Yep.
And if you think that the Earth can pull that much heat that quickly, you are mistaken. You may be thinking you'll just dunk it with dielectric water and it'll dissipate into, well, like for example, limestone is full of air. So even though it's stone, it's still a pretty damn good insulator.
Right.
Okay? So then you'll have to move air down and move air out, which means you have an open conduit. I mean, you already said you're going to use this to heat things, okay? That means you have open air going into a surface. So your second biggest issue, besides earth leakage, is condensation. All right? These are huge issues, and you can do a really simple experiment. Go get a well that's already been dug and abandoned. It'll be full of water. Pump the water out and do whatever you have to do to experiment on this to see if you can keep it warm. And it'll keep it dry. And if you can keep it dry, the second thing is you have to put a heat source in there and see if you can still keep it dry and keep it cool. Because you just have to do a little pilot for yourself to see these engineering challenges. People who put servers underground, they're in big caverns because they still need to run a lot of air and they have to pump a lot of water. So the fact that you're having a closed surface like a bullet tube, you're going to run into a big issue. So like I said, experiment for yourself on a dry well, or pump out the water and try it. That'll be your big science experiment.
My big pushback there is that these experiments have been done with billions of dollars already through the oil companies. The oil companies are going to let water into their oil.
You just said billions of dollars.
I've worked with oil and gas companies locally in
Yep.
this geology. Have you worked with those folks?
Nope, we plan on partnering with them for
You've
sure.
got a lot of limestone. You've
Yeah.
got a lot of empty oil and gas wells in this region. Not necessarily St. Louis City, but just Marion, right across the river, all over this region. What typically happens with these empty wells is you start with horizontal wells. And a lot of them are connected horizontally because it's not like drilling down in Texas, where I also used to live and also used to work in oil and gas. You don't just go vertically down here. Here it's a lot of natural gas and you go horizontally as well. So you're going to be talking about probably drilling some new wells.
Yep.
And you're also talking about doing this, if I understand correctly, are you talking about placing these centers within the city limits? Or are you talking about just using the proceeds of these centers to benefit the city?
Nope, it's going to, right adjacent to the NGA site, straight down.
Okay, you got limestone caverns. Are you familiar with the geology of St.
Yes, so there's a lot of
Okay.
caves. Yep.
Yeah, well, it's more than just a lot of caves. They're all capped, they're all privately owned. There's a whole lot of actual property rights with
The mineral rights.
Right, who owns those caverns, who owns below those caverns, and the water level that's close to the river is really high.
Yep.
So I don't know how deep you're talking about going 1,000 feet, but you're going to have water well before that.
Yep.
So not just condensation, you're going to have to deal with existing water and getting it out.
Are you able to talk about the engineering, the geological engineering of boreholes?
I'm not an engineer, but I can tell you a little bit about it. And this guy sounds like he knows a lot more than I do.
You just said the oil people do this. Oil people have tons of money, and if you're trying to do this as a nonprofit enterprise, you don't have the cash to. I mean, they're maintaining this per well because it's going to make them hundreds of millions of dollars. That's the reason why they spend all the resources to do it. I'm not saying your idea is bad. I'm just saying you have to rethink about where you're putting things underground. It's just a physics issue.
I understand.
Also, NGA, they're not even digging that low on the ground. Like they said, when they started digging, like they're running to a lot of rock in that area.
Yep.
So they didn't even want to continue digging anymore. Yeah, so they had like a big issue at the current NGA site that's happening right now.
Yeah, definitely not going to go too deep with that fiber optics. And we can, if they're okay with it, we can run fiber above ground to their facility. But yeah, they're just doing a flat.
They're not even like maybe like 4 or 5 feet.
Yeah, when they presented here the other day, I asked them if they have any like 20-story secret classified subterranean facilities, and they're like, nope. Government wants us to build this as cheap as possible.
So the question is, who are you talking to? And it's not affordable housing that the problem is. What's going on in North St. Louis right now is the economy.
We are partnered with an organization in St. Louis, the Better Family Life, and we're also talking to the St. Louis Sheriff Vernon, and then also the Judge Jimmy Edwards. So we're communicating with the right people, and it's not just about affordable housing. We're talking about supported housing and getting people jobs.
We'll do the last one. What can the community do for you? Why did you come here?
This conversation right here, I think, is the most important one. I want to be able to convey a very succinct message and fine tune what TerraLock is actually supposed to benefit, and any kind of perspective that's outside of my own, I'd like to take into consideration and really refine the pitch so that we can get started, so that we can get the funding that we need to just get started with the R&D of the technology, but also the social engineering aspect, and get that right as well.
All right.
Thank you.
Thank you. All right.